4. Can you be what?
So we be expected to know, well, like, I can figure out how to graph that without a calculator, but like, not fast, you know?
Well, like those are just lines, right?
Yeah.
So like I would look at that and I would say
True.
that one would be pretty easy. Some of the other ones maybe not so much, right? You know, like, especially when you start getting into curves and it's like, well, the sine be higher than this quartic?
Yeah.
You're right. You could definitely figure it out, but it would take you a long time without a calculator. Now these are lines, so. All right, so I've kind of scratched out a rough picture of this. I've got the red line and I've got the blue line forming the base essentially along with the y-axis. And then I've got these orange equilateral, or at least my attempted equilateral triangles that are kind of growing up out of that, right? And if we went all the way to the end, these triangles out here way at the end would be very small because an equilateral triangle has 3 sides that are all equal length. And so if that base is getting squeezed down, the other 2 sides will be just as small. That make sense? Okay. So then as far as how we set this up, it's got to be volume of that solid by cross-section equals the integral from somewhere to somewhere. Let's decide this. First of all, are the cross-sections dx thick or are they dy thick? Dx, yep, perpendicular to the x-axis. Okay, and then we're going to integrate from which x value to which x value? 0 to 2. Okay, so 0 is clearly over here. So you guys are saying that that's 2? Okay, so 0 to 2. And then, of course, what goes in there is the area of the cross-section in terms of x. And this is where you could have some wildly diverging efforts, right? Here is one thought. These are equilateral triangles, and so somebody could easily look at those and be like, well, you know, like Emma's question is like, how do we find the height, right? And that's a good question. You could derive this pretty quickly. So, for instance, if I looked at this, if I looked at this base right here, how long would you guys? Obviously, the base is going to be different depending on where you're at in the figure. How long would you say that base is? Like, how would you describe it?
2y.
It's 2y. So if I were to just take this this triangle over here and say, all right, I've got this triangle. I know the base length is 2y. If it really is equilateral, wouldn't these other 2 sides have to also be 2y? Yeah? And so then we start to think, well, the area for a triangle is just 1/2 BH. And I know that my base is 2y. But then, of course, my height, right? So here's what I could do. I could drop an altitude down from that top vertex and essentially create 2 smaller triangles where that red line is my height. So I'll just draw one of these over here. So this is height, and this is 2y. How long would the base of this smaller triangle be?
Y.
It would just be y, right? Because it's going to be half of the 2y because we dropped an altitude down on an equilateral triangle. And then I could use the Pythagorean theorem to find the height. So it would be y squared plus h squared equals 4y squared. H squared then equals 3y squared. So h equals root 3 times y. Sorry, I ended on kind of a bad spot there. Does that make sense? Liz?
Could you do like the Pythagorean triple? It's like just 1, 2, 3. So the h would be.
Sure, yeah. So 30, 60, 90. You could do similar triangles with that. Definitely. Definitely could. Ashley, you doing okay? Okay. All right, so then my height is root 3y. So then finally my area formula would be, I guess it would be root 3y squared. Does that work? Okay. So then I can then come over here and say volume equals integral from 0 to 2, and it would be root 3y squared dx. And of course we have a little issue here because y, x, right? So what could I use to replace the y?
F of x minus g of x.
Yep, f of x minus g of x. So, let's see here. Yeah, f of x minus g of x. So that would be what, negative x plus 2?
Yeah.
So integral from 0 to 2 root 3 times negative x plus 2 quantity squared dx. And now we're in a pretty good spot. So let's just rip through these next couple of steps here. So it'd be root 3 times integral 0 to 2, and it would be x squared minus 4x plus 4. And then root 3 times 1/3 x cubed minus 2x squared plus 4x, evaluated from 0 to 2. And then it would be 8/3 minus 8 plus 8. Eight root 3 over 3? Did I mess something up? What did I mess up?
Somehow your area, because you have the base of your triangle equal to 2y,
Uh-huh.
and yet you have, once you put it into your integral, you have your base of your triangle equal to y.
So he took out the 1/2, right?
I'll see here. So what I did,
Put 2.
so I set up area right there, area of the cross section, 1/2 times 2y.
But I don't understand why the base of your triangle isn't y.
The base of my triangle. So the base of my triangle goes from here to here,
And what would you call that?
2y.
So y in your integral, do you have the base listed as y?
Y in my integral. Well, so what I did, so do you agree that that's 2y? So what I did, this is my area formula, 1/2 BH. And then I said my base was 2y. Unless I messed up my derivation of my height. And I said 1/2 times 2 is 1. Y times y is y squared.
I don't know, just everyone else has root 3 over 4 as, yeah, everyone else has root 3 over 4 y squared.
Show me where I messed up. Like I said, I'm kind of out of it, and I wouldn't put it past myself to lose something, but I just don't see where I messed it up. Can I do this? Here, I'll show you. If I honestly, like I said, I'm like about 50% here, so I could have messed this up. What I would have done is this. I would have said that the area formula for an equilateral triangle is this. Like that's the area formula, where S stands for side. So let me do it this way and see if I somehow messed it up. So then it would be, side would be, that would be the negative x plus 2. So it would be negative x plus 2, quantity squared times root 3 over 4. And that's where, okay, yeah, I get it, but where did I, honestly, I'm not seeing where I lost it.
I changed the 2y to the top function minus the bottom function. So I leave in u y there. And then I denoted it as some variable x in my derivation. And then substitute those functions as x.
Where did I want to see my students right now. What's that? Yeah,
Should I do it with, instead of factoring out the negative x plus 2 squared, just
Oh,
do the power?
I actually see where you messed up, Mr. Ames.
where did I mess up?
So when you have 2y, you have 2y equal to f of x minus g of x, right? So when you put in y squared, it should be f of x minus g of x halved.
Over 2. Yeah, no, I get it. I get it. I think I do. Yep. Yep. That's what it is. So check this out. So it was on this step right here. So I replaced the y with top minus bottom. Top minus bottom is not y. Top minus bottom is 2y. Make sense? Does it make sense? So if I just replace this, or you know what I could have done? This would have been, this actually makes a little bit more sense. Couldn't I have just replaced y with what y equals? Either one of those, right? I could have replaced the y with negative 1/2 x plus 1 or 1/2 x minus 1, which would have changed this, which would have arrived at root 3. Let's see here. So,
But then if you plug that in, if you plugged one of the line segments in for y, you would have to divide it by 2.
say that again, Cameron?
If you plugged one of the line segments in for y, then you would have to divide it by 2.
Correct.
Why?
Because literally y, so it was a mistake on substitution.
Oh, okay.
So like what I did originally is I replaced y with top minus bottom. And top minus bottom, if I can come back over to my picture, top minus bottom from here to here, that's not y, that's 2y.
Okay.
So what I actually want to do is replace y with what y equals, and y actually equals negative 1/2 x plus 1.
Okay.
Or 1/2 x minus 1, and because I'm going to be squaring it, I don't think that it matters either way. Okay, so let me see if I can finish this out real quick and make sure that I've got it. So it would be root 3 integral 0 to 2, and this would be 1/4 x squared minus 1/4 x plus 1. And then so let's see here. That would be 8/12, 2/3 minus 1/2, so it'd be 2/3, 4/6, 1/6. This is feeling weird too. Help me out here, guys. Like,
the square wrong. It should be 1/4 x squared minus x plus 1.
it should be what?
In your integral, it should be 1/4
to-
x squared minus x.
X plus 1.
Oh, minus x. Doggone it. I am struggling. I hope you can forgive me. Normally I don't have these problems, but literally, I'm struggling.
Yeah. Like for a long time.
And it's the details, right? The concept is no issue, it's the details. Okay, so let's try this one more time. This is just for my own curiosity. Can I do it? 1/12 x squared. Like literally, can I make my pencil do what I want it to do? Okay, so then 1/12 x cubed. Almost couldn't do it. We finally agree? Is that what you guys got as well? Okay. All right, well, there you go. That was probably more entertaining than you bargained for. Liz, are you just doing a picture or something?
Yeah,
Okay.
so I can redo it.
Okay, sorry. I normally never lead you guys astray, but I totally did. Okay, are you guys okay with the concept?
Yes.
Like the fact that I was struggling to add and multiply, whatever. Okay. So let's do this. Let's go ahead and look back at what we finished with last time, and that is the length of an arc. And so, what do we have here? Does this class go till 40? 35. 35. Okay. So I was thinking about showing you a different way of deriving this, but I kind of shot myself in the foot there. Maybe I do or don't have enough time. So last time we looked at one way of deriving these arc length formulas. And you can do the arc length. You can find arc length by using y's. You can find arc length by using x's. Certainly up to you. I think one way or the other will lend itself to being a little bit easier, but they both do work just fine. And then just one more reminder, no matter how you set these up, all your variables have to match, including your limits of integration. So I thought we would do a couple of examples here, one of which is really like, detail-wise should be easy, although I've proven that it can make anything difficult, I suppose. But you should get the same answer regardless, right? So if we're talking about the arc length of a parabola, like how long is a part of a parabola, whether I use x or y, it should be the same. So I thought maybe we could do the x's together here, and then I'll have you guys try to do the y's together. So if we're going to be finding arc length, we're going to start off with our formula. Arc length, maybe represented by the letter L, is equal to the integral of the square root of 1 plus the derivative in terms of x, quantity squared, dx. Keep in mind that that comes from the distance formula. And so as I start to fill in my limits of integration need to be x's as well. And so my low x would be 2, my high x would be 3. And then it would just be an issue of getting these, getting the f prime plugged in. So arc length would equal integral from 2 to 3 of the square root of 1 plus 2x, quantity squared, dx. So then what do you do with that? I'm thinking that this would be a calculator active question. I don't think that integrand is going to work out nicely. And so maybe grab your calculators, use Math 9 to get this going. Let's get an answer for that. Let's see if we can adapt it to using the y's as our variable of integration. .26 point something, Emma?
Is there something going on today? Because there's like 4 ambulances and fire trucks.
26 point what did you guys get?
I don't know, but
Did you guys get 26 point something?
I got 5.1.
5.1? Well, it looked like there was 0, 0 after that.
Yes.
Okay.
I got 5.1
There you go, yeah, put the squared on the outside.
Why'd you say
Okay, yeah, that's what we got too. Did you guys get that 5.100? 3? Okay then. Would you guys try the same thing only using y's? You know what the answer ought to be, so this should be easy to check. Now please try the exact same thing, only use y's. Be right. It better be 5.001. So let's just make sure we have our setup right. So did you guys have the integral from 4 to 9?
yes.
Okay. And then square root of 1 plus something squared dy. And then as far as what goes in there, you've got y equals x squared, and so we need a slightly different version of the derivative. What did you guys put in there for your derivative?
1/2 y to the negative 1.
There you go. Good. So 1/2 y to the negative 1/2. And that, of course, comes from saying, well, if y equals x squared, square root of y is equal to x, right? And then you just differentiate that. The squaring, I guess the squaring actually helps you. Maybe you could have done this one without a calculator. But did you guys get that 5.100 still? Okay, awesome. So then the final task I have for you today is example number 2. Example number 2
Yeah.
is obviously a very different looking graph than what we had before. We've got this x cosine x plus 4 and this other line, both on the interval from 0 to 3. R is that region there you can see labeled. So it says, write an expression involving an integral that expresses the length of the boundary of region R, so like the full boundary, and then use your calculator to try to evaluate that. So this will be our final task today. See how it goes. Pretty good. And as maybe a hint, I don't know, you guys know that technically a straight line is still considered a curve? It's just a straight curve, essentially. So in other words, any formulas that you might use to find the length of a curve can still be used to find the length of a line. So consider. So let's see here. If you're going to find the length of the curve, perhaps first, because you got to basically add the curve's length to the line's length. Does that make sense? So I'm going to say the length is equal to the integral from somewhere to somewhere, square root of 1 plus, and if we're going to do the curve, don't we have to do the derivative of that? X cosine x plus 4.
I should 0 to 3.
Did you guys remember the product rule here? Good. Okay, so 1 d2 plus 2 d1, and the whole thing should be squared. What kind of limits did you guys put on that first integral for the curve? Say again?
0 to 3.
0 to 3? You guys have 0 to 3 as well? Johnny, what do you say? 0 to 2.094?
Yeah.
Oh, that's
Right here? So it's got to be, so the intersection point is not a 3. I honestly don't know. So it's 2.094? Okay. And that's the x value. Do you guys agree with that number?
Yes.
Okay, 2.094. You don't agree with that number?
Well, no, we were asking if we could pretend like it was 3.
Oh. Okay, so 2.094. So this should be the length of the curvy part of R. But then we need to add to that the length of the line, right? So you could just do the straight up distance formula for the line segment if you wanted to. Or, really honestly, what you could do is just another arc length. You really could just say, well, the integral from 0 to 2.094 of the square root of 1 plus. The reason why this might be easier is because the derivative for this line, super easy, negative 0.5 dx. And that essentially is the distance formula right there. Okay, so you guys have essentially that? Do you have any questions on anything there? Okay, so then the only task that remains would be to then use Math 9 a couple of times. And did anybody have a suggested answer? Something you all came up with? 5.508? Okay. We get agreement on that numerical value? Did you guys get 5.508 also? Okay. Okay. So I'm hoping that one of your takeaways here is that finding arc length, as long as you have your formula down solid, not going to be the hardest thing you do this year. Liz, looks like you might have a question.
How would you do the antiderivative of the sin x, cosine x business?
Well, first glance tells me probably you're not. So this would probably almost for sure be a calculator active question. I'm guessing it's going to be one of those crazy formulas, right? With substitutions and so on and so forth. Anybody else with a question, concern, anything?
I got a different.
You did. 5.508.
I got 5.11.
Oh, I got 5.596.
You got 5.596.
597. Yeah, kind of weird.
I keep saying non-real answers. I'm not super sure what to do about that.
This 2.094, I'm assuming is a rounded number. I'm guessing that that's probably part of it.
This is pretty close.
See you guys. Have a good day.
No, later.
Hey, when you guys got 5.508,
It just says error.
they're saying they use the unrounded version for this number. It looks like you're,
Yeah. I don't know why it's saying that.
but if you want to get the exact same answer, you're going to use the unrounded version.
Jordan didn't round, but I did round, and he got 5.509, and I got 5.5.
But he's getting like 5 point something 11. So it was really close. It was really close then.
Did you check that you put in minus sign, x sign x? Because that's what I was missing.
Oh, that x needs to be in the square. It is. No, it isn't. Is it? Yeah. You said it multiplied by. No, it isn't. You got x times. You're inside that is wrong.
Where is the question?
So you've got x times both sine.
What did you
yeah.
do, Alex?
The x just needs to be times the first
It's
term.
supposed to be square.
Are you?
Oh, yeah. Oh, no, I'm just happy. You're signing?
And then squared would be, the whole thing would be squared.
Thank you, Mr. Anderson.
Thank you, Johnny. Have a good weekend. No, we still have class. I'll see you tomorrow. Emma's leaving, so I told her have a good weekend, so. Yeah. I'll see you tomorrow.
Thanks,
Yeah,
Mr. Anderson.
5.5.
Do that kind of business.
5.508. Yep,
Thank you, Mr. Anderson.
yep. Thank you.
Parentheses.
Darn parentheses. Okay, so you're good. Liz, did you ever figure out the whole non-real thing?
Yeah, I didn't square it.
Got it.
Ricky